Thank you, Alex. That was a great overview of the Interledger protocol and a lot more information about the foundation itself. So we're going to hear more about that later, so hang on in there. Next, we're going to welcome back Joseph Yyolk, owner of UOVO LLC. He's now going to give a presentation on a new programmability feature on the XRP Ledger called hooks. He'll go over the proposal, and he'll tell you how it works.
Thank you, Jazz. My name is Joseph Yyolk, and thank you, Alex, for that awesome overview with Interledger. Today we're going to talk about, my talk is titled Loosely Hooked at the Edges, and what it's about is the internet. It's pretty awesome, right? So the title of the talk is inspired by David Weinberger's book, Small Pieces Loosely Joined, where he talks about how the web has unified and is going to basically create a new reality. It's basically transforming bedrock concepts of our culture, such as space, time, the public, and even reality itself. So if you think about the web, we have basically disparate services. We have protocols, HTTP, FTP, HTTP, email. These things don't actually work on a blockchain, but they worked really well for years. So I want to talk about the definition of a smart contract. Software that is enforcing the terms of a contract-like arrangement between third parties. This definition comes from Dean Tribble and Mark Miller. You might know Dean and Mark Miller in the space. Dean's now CEO of Yyolk, and they're building a blockchain with JavaScript. So I want to really press this. If you can write a function, you can make a smart contract. That is what it is. It's some function in the blockchain. I kind of think of it like a stored procedure. So if we don't need to, let me play a little devil's advocate here. We don't need to put the smart contract in the chain. Can we fulfill that sort of like gap that we're expecting, or cypherpunks are expecting? Can full transparency fulfill that trust? So the colloquial definition of smart contracts run in a network akin to stored procedures in a database. We already do horizontal scaling. So like when I hear about we can run this on many computers and they'll have the same results, well, we sort of already do that when we ship code in production. Database transactions, very similar. When you have many users hitting the same database, you often will make a transaction, so those fields are locked and not modifiable by anybody else. So I would say they're pretty much identical, except where do you deploy it? So I want to talk about eggegg, egge.gg, and this project, I think, basically, it's sort of emblematic of what I'm trying to present here. So full transparency, all code deployments and development is done in a public GitHub repo. It's a function as a service. I think this is what developers really actually want when they talk about smart contracts. They don't want to actually deal with the infrastructure. And it does transactions. It writes to the database, the XRP Ledger, and it's gathering information from the web. So I'm going to show this repo, and we're going to walk through a little bit how the transparency is working. So if you go to eggegg today, you get it's basically a view into the Oracle. This is a WebSocket connection to the XRP Ledger. Every time it's updating, this will highlight with an update. These are metrics every time it successfully published a transaction or a price metric. And this project itself was inspired by Wietze's price persist Oracle, where he's running it on a VPS. I wanted to take it a step further. I wanted to basically show that you can run things for free using like infinite free storage tiers. I'm sorry, infinite free execution tiers on AWS, for instance. So this is the repo. Everything is deployed from here, and everything is done in the open here. It's open source. We match the git commit to what is the last transaction of it. So if I go to the Explorer here of the last transaction it did, and I'll have to open this in another scanner. Let's just go with BitHomp here, since we want to decode the message. And this is basically what it's publishing every minute. We see the rates as separate memos, and we're taking advantage of the memo types, which are basically headers on these fields. And then the metadata, sorry, the body of the memo is here. There is a content type that is displayed, I'm sorry, not displayed, but also included, but we're saying no text CSV. Included here as well is a memo of the Git SHA that is running this. So if we look back at the repo, we can see it's ETC2B91C. The last transaction was ETC2B91C. I'm going to make a superficial change to the README so that we can see a deployment quickly. We'll just add a new line here. Since this will be in history, I want to make sure I have a poignant message. And we'll go to our actions here. Hi from Apex. So every deployment happens in GitHub Actions. It was just convenience. We deploy from here. This is using stored secrets within the repo. In the future, I'd be using OIDC so we can spin up credentials on demand, and I wouldn't have to necessarily include my own AWS account. So this should only take less than a minute. It's building the repo, it's gathering so the project itself is written in Python. I'm using XRPL Pi. It's a great library, you should all try it. But it really got me to the end of this in less than a weekend. I was able to pull data in, publish metrics with memos, following Witsy's example, and then everything else was just planning the infrastructure. Again, this is serverless. It's an infinite free tier. The way I'm running this is once a minute. They actually have such a huge headroom for execution of what they call Lambda functions that this is, if they were to try to charge me for how much I'm actually using, it's negligible to them. So there's an infinite free tier. I'm taking advantage of that. Running this every minute for a year costs about 5.16 XRP. So now it's just updating the actual stack here, updating the function code. It was superficial. It was just a README change, but there was enough of a change there that we're packaging that README and we're also updating the git commit. So we're now at FDD to F1E. If I'm lucky, it's already published. We'll see. Not yet. Let's go back to AGEG here. It's every minute, so we'll hit it soon. But I just want to connect the Git SHA update. This is 1841. We might have to wait a little bit longer. I guess I would say that the way I broke this out is it's a simple one file module. It's a Python module. All the code is here. It's procedural. I hope anybody who doesn't know how to code will be able to understand this, because I really think that getting people crypto literate is going to enable a lot of people. And unfortunately, maybe that has to deal with understanding how code works. And if I can step you through it, maybe that's a way to get there. And so we have the new commit here. So I'm going to go back to my slides here. So let me say, again, these points, full transparency. The code is written in the open. It's deployed from where you see it, and like review it. It's a function as a service. This is what I think most people want in smart contracts. They don't want to deal with the infrastructure. It does transactions. It gathers information from the web and then writes it to the ledger. So XRPL hooks. I barely start, just as a forewarning, I barely scratched the surface. That stuff is super cool. I'm going to break it down in a way as like essentially a hot take from my compounded heuristics over many like years of using technology. So the way I looked at hooks, so if we look at hooks on the left, edge routers on the right, I kind of brought it to that sort of network topology. So when you have hooks are set on accounts, edge locations are where you install edge routers. Hooks work on ingress and egress of funds, so into the account and out from the account. Edge routers, very similarly, packet switching, ingress and egress, where it's the gateway for that subnet. It's sandboxed. Also, hooks are sandboxed. I would say hooks are more closer to web browser sandbox, where an edge router is sandboxed because it's essentially the network dictator, I think, at that point. So just the hook examples we can see from Weetzy's dev.2 post. These three examples pretty much will outline my feeling about edge routing and hooks. So carbon offset hook, it's a split pay input valued to many outputs, and something comes in, it's bifurcated and split out. This is done on the ingress of funds, and it's done when you do an account set. That code is your hook. So it's actually called account set hook or something. Firewall hook is another example. It's a basic like block list of denied addresses. And then the light account hook, which is also now I would say, a new proposal or standard, is using a single account where tags were used, and hook state is where basically the public keys. This is a pretty good advanced topic, so what I like about these sort of posts that XRPL Labs will do is they get you in real with like the simple examples, then they go real advanced. So loosely hooked at the edges. I guess my takeaway, or what I want people to take away here, is that hooks will be able to do a lot, and they will serve a need. Just because it doesn't have those capabilities we have in the EVM doesn't mean that we need them. When it comes to infrastructure, if you need to not care about servers, look at serverless. Do you actually need a stored procedure, or can you use application code? We've done it for years. Really be transparent, open source the code, deploy the code from the place where it's seen, reviewed. I think this kind of closes the loop on sort of any sort of taints going into that. When you have an opaque, when you don't provide the inputs, so let's say I want to verify your outputs, I want to know what you got inputted. So you can either return that as a memo, or you can show that through some functionality. And then shared functionality seems like a interesting idea with hooks, since at this point we want to have, at this point you can install one hook and you can have that application or hook do multiple things. But since these are objects or accounts on the ledger, if they take some input that we can change or modify for our needs, maybe there's a way to have shared functionality within the ledger with hooks. And that seems pretty interesting. So transparency is a good path regardless. I think a lot of smart contracts, you'd be surprised to know that some of their stuff is not open source. Where can we blur the context of what a smart contract is, what is application code, and when do we need to actually not care about servers? Can we change our infrastructure plan to more closely match what we expect in smart contracts, and then, in normal application code, handle the database transactions as, the crucial part of our application? And I guess think about, the takeaway I want people to think about is, if your idea of a smart contract was just so you don't have to run servers, there's better ways to do that. And I think if you have some application code, there's definitely a way to talk to the ledger. The RippleD has some great APIs, JSON RPC, WebSockets, and gRPC. They're pretty modern too. If you've used any modern or done any modern web application development, it would make a lot of sense to you. Thanks.